Okay, let's continue our discussion of electricity by starting off looking at charge. So in my introduction video and a little bit in my circuitry video, I did start talking about what charge was. And what I said was it is an intrinsic property of something. So let's really break that down and realize what that means. So let's say you take a ball, okay? And that ball has a certain mass, it has a certain volume, it has a certain temperature. These are all facts about that ball that we know. We can change these things about the ball. We can change its mass. I could take a bite out of it. We could change its temperature. I could put it in the fridge. But it is an intrinsic fact about that ball. Whether we can change it or not, it has these properties. And this ball, along with everything else, also has a charge. There's no other way of defining charge, really, apart from it is how charged something is, which isn't a great definition. So this whole idea of charge, okay, comes about essentially from the electron. The electron is a fundamental particle, floats around inside most atoms, and it is charged. Specifically, it is negatively charged, which is why the electron has this little minus sign usually when we're writing it. And the electron is very, very important in charge. In fact, it basically is like saying it is the fundamental units of charge. All charges around us only exist in units of the charge of an electron. So, getting a bit ahead of ourselves, but let's have a look inside of an atom to start with. In an atom, or an egg, whatever I've drawn, we have got some protons, some neutrons in a nucleus, and we have got some electrons floating around in a cloud or plum pudding, depending on what you fancy, floating around outside of it. Now, the protons are a positively charged particle, P+. They are a positively charged particle. Neutrons, as the name suggests, are a neutral particle. They have no charge. And electrons, as we've discussed, have a negative charge. And what happens when you have like charges or opposite charges is they interact with each other through something called the electrostatic force. And this is a force that acts between all things that are charged. So it acts between electrons that are next to each other, it acts between protons and electrons, and any multiples of the two. If you have two like charges, as I'm sure you're aware, they will repel. If you put two electrons next to each other, they will repel each other using this force. Two protons will do the same, but a proton and an electron will pull each other together using the electrostatic force. Negative and positive come together, like charges repel. So, what does, atoms and electrons and protons have to do with this? Well, what we have demonstrated, I say we as if I was involved, it was Millikan's oil drop experiment specifically, if you're doing A-level, you do need to know about that, demonstrated that everything in the universe that is charged, so for example, a balloon that one would rub on their head and stick to a wall. I don't have a balloon and I don't want to mess up my haircut. All of these things are only charged because they have a certain multiple of electrons or protons. Everything that is charged because it has an imbalance. If something has 2 electrons and 2 protons, I have 2 negatives and 2 positives and they cancel each other out. But if I had 4 electrons and 6 protons, I only have 4 negative charges and I have 6, that is not 6, but I can't let go of my pen, 6 positive charges. So this object with 4 and 6 would be positively charged. It will have an abundance of positive charge. Now multiply these numbers by a couple of quadrillion and you end up with your day-to-day objects. your balloon that you rub on your head and stick to a wall will have an imbalance of billions and trillions and maybe quadrillions of electrons and protons. And more or less, that's all charge is. Anything with a charge simply has that charge because it has an imbalance. An ion, for you chemistry lot, an ion has an imbalance of either too many electrons or too few electrons, so too many protons, and we have that imbalance. And circling back to what Millikan discovered, was that not only is everything charged because it has multiples of electrons or protons, but also it is charged with multiples of the charge of an electron or a proton. Now, the specific charge of an electron is minus 1.6 times 10 to the minus 19 coulombs. And this is an incredibly important number in physics. So let's break down a few things. First of all, the minus sign is here, go figure, because it is a negative charge. Then this value here, 1.6 times 10 to the minus 19. This is the amount of charge that an electron has. And C for coulombs is the unit of charge. Whenever you're measuring the chargedness of something, you measure it in coulombs. Same way you measure mass in kilograms, it has its own thing. And because every electron has this value of charge, every proton, in order to counteract it, also has the same value, but this time positive. A proton has a charge that is exactly the same when it comes to the magnitude, but it is a positive. So if I have 1.6 times 10 to the minus 19 coulombs coming one way, negatively charged, and plus 1.6 times 10 to the minus 19 coulombs coming the other way, they will cancel each other out. You add them together, they cancel each other out, and that's what's going on over here. And because these have very, very specific numbers, and because they're the same numbers, no matter how many trillions or billions or quadrillions of electrons we have more than protons, or the other way around, our charge is always going to be a multiple of this number. Every time. You cannot have an object that has a charge of 1.3 times 10 to the minus 19 coulombs. Or half of this, 0.8 times 10 to the minus 19 coulombs. You can, of course, have a charge that is 2 times this. In fact, this situation here with a 4 and a 6 will overall have a charge 2 times the value of this. But you cannot have something that is not a multiple of this number. Simply doesn't work, because you can't have half an electron giving you charge or half a proton taking it away from an electron. So charge overall is just based on the behavior of these guys, these electrons and these protons. How many or how few do we have of each? So linking this into our electricity and our circuitry, when we have anything with a charge, doesn't matter what it is, could be an electron, a proton, or a sodium ion, could be anything at all. If it has a charge, it is going around a circuit, it is causing electricity, simply by definition. You move one of these guys, you have electricity. And what we'll notice as we start to do circuit equations and a bit more complicated maths in upcoming videos, you will notice that we can use this fact that charge is always multiples of one another, of this number exactly, to find out how many electrons or charge carriers do we have in a circuit, how fast are they going, and then all associated things. So that does it for charge. I think next we will move on to current, voltage, resistance, and then we'll package them all together nicely into some circuit analysis.